Good morning, everyone. Yes, good morning. Okay, so can you all hear me? Fine, very good. So these were some homework questions for you. I would hope you would have solved these. Okay, Vedant. Does anyone have any questions with these seven? Okay, all right. Hmm. Okay, fine. So there is some. There seems to be some problem with 4, 5, and 7, right? In general, sound is not too low. I believe most people can hear me. All right. I think it's going to be okay. Yeah. Okay, then I'm going to start with 4. I'm going to start with 4. I'm not going to take a lot of time and explanations will be rapid. So we have to do integration of x cubed by 3 dx from 1 to 3. So first of all, 1 by 3 is outside because it's a constant. All right, kick the constant out. And now x raised to 4 by 4. Clear? And then you put 1 and 3, right? So this is going to be 1 by 3, 3 raised to 4 by 4 minus 1 raised to 4 by 4, right? So that is equal to 1 by 3 and 1 by 12. In fact, if you want, you could just write it as 3 into 4. 3 raised to 4 is 81. 81 minus 1 is 80. So you can cancel this. Okay. So we're getting what? 20 by 3. What answer did I give? Yeah, 20 by 3. Sorry. Uh, yeah, fourth one, 20 by 3, right? This was fourth, right? We did the fourth. Yeah, okay. Clear? Okay. I really don't know, Vedant. Okay. In my in my opinion, they are thinking that you have a test on Monday, right? You have one or two chapters test. Okay, and that's not really too much in my opinion, right? One or two chapters is nothing, right? You'll have 15 when you have your final exam, right? And 30 when you have JEE, and 30 of physics, and 30 of maths, and 30 of chemistry. Just like that, biology students will have 30 of biology, right? So, very frankly, I don't agree with their decision to not ask you for the homework. All right? Hey, okay, never mind. Right. So, but I always tell this to all my students, and here's your first attempt or first try or first chance to listen to it. It is that if you are going to do homework just because you have to submit it, then I would say that your academics are going to be very bad, right? All of us, we should do our homework for learning, right? If you learn, everything else will come on its own, right? So please always keep that in mind, right? Okay, so that's number 4. Now number 5. So 20 upon x square. So I hope you realize that this is this. Clear? Okay. I don't think anyone has any problem with that. Right? 1 upon x square is x raised to minus 2. So just use the usual rules now. 20 outside. Integration of x raised to minus 2 dx from 4 to 5 is going to be x raised to minus 1 upon minus 1. Clear? Right? And then you have to put a 4 and a 5. Okay, so this will become 20. Now, you see, this is a minus sign, right? Okay, but what I could do is I could write x raised to minus 1. I'm sure all of you understand is this, right? So this will become 1 by minus 5, okay, minus 1 by minus 4, all right? Or you could just write minus minus plus. Clear? Okay. So this is, I will just multiply 20 inside. That makes it very easy. Ooh, okay. Okay. So we're getting plus 1. Interesting. What did I write? Did I write minus 1 or plus 1? Okay, I wrote minus 1. I made a calculation mistake, it seems. Right? I made a calculation mistake. I have to admit my answer was wrong. This is okay. This is correct now. All right? The correct answer, yes, the correct answer to this question should be 1. All right? Not minus 1, it should be 1. Clear? Okay. And now, frankly, now I realize what stupidity I would have done, right? I forgot to put that minus sign, perhaps, this one, right? Okay. Is this clear, everyone? The answer that I gave was wrong. Okay. This is the correct answer. Plus 1 is the correct answer. Okay. I made a mistake in calculation. See, everyone does that, right? I am speaking loudly, Priyansh. Use your earphones. Come on, I'm shouting over here, right? Everyone, I request you to get full volume on your device, right? I cannot go any louder. How many of you can hear me clearly? Okay. So most people are able to hear me clearly. I don't need to worry about it. Okay. Yesterday someone told me, sir, speak slowly. It's too loud. All right. Now, let's go to number 6. Yes, Vedant, you are right. I just made these questions myself, right? Okay, Krisha. Number 6. All right. Now, for number 6, I really don't think I need to do it. Anyone wishes me to solve number 6? Anyone? Okay, fine. Let me do it. All right, I'll do it. Let's see what happens. Okay. I hope I just didn't make another calculation mistake. Sometimes I tend to do that when I want to. Kunal, were you present yesterday? No, it's fine. I'm used to this. So then, Kunal, I don't think you have a right to answer such a question. Kunal, it was integration symbol, right? This is the symbol of integration. Okay. This is the symbol of integration. Yesterday we learned that technique. Okay. So here you have 2 and it's going to be x raised to 4 by 4 plus 4x squared by 2 minus 3x. See, everyone, I would request you, if you have a network problem, please try to adjust, right? Use someone else's phone, use someone else's network, data, something, right? I hope you realize when I have a network problem, what I'm doing, right? I'm running to the school 3 kilometers away from my house immediately, right? So I hope all of you are committed to learning, right? Just like I am committed to teaching you. Okay, so network problems are a reality for all of us. Once in a while, we'll have those. So when such a thing happens, don't just sit idle. Try to find some solution. Okay. All right. So this is what we have. Okay. So I hope the integration part is clear. Wow, Vedant, that is wonderful. So this is going to be 2 raised to 4 minus 1 raised to 4 by 4 plus 4 2 raised to 2 minus 1 raised to 2 by 2, okay, and minus 3 into 2 minus 1, right? So this is what we get, right? And now you can cancel this 4 with this 2, all right? This here, okay, let's see. Now 2 raised to 4, 16 minus 1, 15, 15 by 2 plus 6 minus 3, okay? All right, I see. So this is 15 by 2 plus 3. So I got this answer also wrong. Very interesting. How many calculation mistakes I have made over here? Yeah, I got this one is wrong. Let me just confirm this. Let me just confirm this, right? Okay, here we have a plus. Here we have this. Okay. Hmm. 2 and a 4 and 2 raised to 4 minus 1 raised to 4 upon 4 plus 4 into, yeah, okay, fine. Yeah, this does look correct. 2 into 3, 6 and 15 by 2. All right, yeah, this is fine. Okay, one more answer was wrong on my side. I'm going to stop giving answers now. All right, I'm going to stop giving you answers. Yeah, possible. Why is it minus 3x? Uh, See, if it is integration of 3 dx, right? This is the last term, all right, Raj? This is the last term. Then 3 is a constant. If you put it out, then you get this. Then integration dx is x. So this is how you get minus 3x, all right? Okay, right. Hmm. Looks like I would have taken this as minus 3. I would have definitely made some mistake in here. Anyways, all right, so this is the correct answer. No problem about that now, right? What? 4 minus 1 is not 6. This is 2. You're forgetting that. Follow. 2 into 4 minus 1. So 6. All right. Okay. Right. So this is it. Now let's go to 7th. Okay. So let's do that now. This is a big question. I won't be able to remember it. I'll just copy it from here to there. Okay. Right. So here is the 7th. This is equal to 3 by 2 root x dx. Here I am writing steps so that nobody gets confused. Okay, right? So first step, here we have used addition subtraction rule, and then we have kicked the constant out, right? Okay, I hope all of you are seeing that. Fine. Now this is equal to, see, root x. I have mentioned this earlier and I really hope now everyone remembers. Root x is equal to x raised to 1 by 2. All right. ઓકે, લખવું હોય તો લખી લેજો. આ છેલ્લી વાર, હવે નહીં આવડે તો હવે તમારી રિસ્પોન્સિબિલિટી. Root x is x raised to half. So basically I'm saying that means square root means half power. Square root means half power. All right. And similarly, cube root means 1/3 power. Okay, this you would have studied in ninth, I'm sure, right? Or before that, I don't know, right? Okay, so please, yeah. So I'm saying that square root is half power and cube root is 1/3 power. Please don't forget it now, everyone. Okay, so we are going to use that here. 3 by 2. This is x raised to 1 by 2, isn't it? I hope you understood what I'm saying. This is x raised to 1 by 2, right? So now if this is x raised to 1 by 2, then this is going to be x raised to 3 by 2 upon 3 by 2. Clear? Again, it's like this. 1 by 2 plus 1 by using rule number 1. Okay? By using rule number 1. All right? And similarly, over here, I hope that makes sense. Okay? Right? I want to know, is this step clear, everyone? Then I'll proceed. Is this step clear? we are using this formula, right? Okay, just compare this n with what we have here. We have square root. Square root means 1 by 2 power, right? Okay, I hope you understood that. So I'm just using that formula, right? Okay, Shreya. And just like that, for here it is x raised to 1 by 3. So there n is 1 by 3. So again, we are using the same formula, right? We are using the same formula over here in the second term, right? So let's continue with it now. Okay. So this is equal to 3 by 2, right? And you know why I've given this 3 by 2 here? So that this 3 by 2 and this 3 by 2 will get cancelled. Okay? Right? So don't try to do anything fancy. Okay? Minus 4 by 3 over here 64 raised to 4 by 3 minus 1 raised to 4 by 3 upon 4 by 3. Right? Okay? So finally, we have got this. Now, this is where it becomes very nice. Okay, I really like this part of the question. Okay, just a second. This was 4 by 3 in the question. I want to confirm that. Right. So this answer is also wrong. You can congratulate me for getting a hat trick. I think we'll get 0 now. I think we will. Thank you so much, people. Kunal is most eager, right? So now here, let's see what happens. First of all, 64 64 raised to 3 by 2. Okay, right? So how to do that? Well, this is how you do it. First you do raised to half and then you do a cube, right? You may have studied a property like this in your 9th standard. Okay, 1 by 2 plus 1 is 3 by 2. Okay, minus 1 raised to anything like this is 1. Okay, no need to worry about that, right? Minus here again 64 raised to 4 by 3. We are going to use the similar property like this. I hope you realize why I chose 64, because 64 is both a square root and a square and a cube, right? So now 64 raised to half is 8. So this is 8 cube minus 1 minus. Yeah, the answer is 256, right? And this is 64's cube root. So 4 and then raised to 4 minus 1, right? The answer is 256. Final answer will be 256. Let's see how. 512 minus 1 minus 4 raised to 4 is 256. You can check that. You can check that if you want. Okay. I'm absolutely sure about that. Minus minus plus 1. So these two are cancelled and you get 250. Right? I'm almost kicking myself here. I'm thinking, what have I done? Right? I gave you 7 questions and gave you 3 wrong answers. Right. Yeah, Rohan, it happens, and it does happen quite often with me, right? You know, uh, that actually makes me tell you that there was only one thing that I always used to hate in maths when I was studying. There was one thing that I always used to hate, and that was this, right? That was this statistics, that is mean median, okay, and all that. Okay, right? And I know that this is quite different. Like generally, people really love these things, right? Because in 10th standard maths, in 10th standard maths, they would find this to be the easiest, right? I agree. This is disgustingly easy, right? And you know, if you'd realize, if I'd make the replies public, most of you are going to understand that this is such a interesting thing, right? Some of you are saying boring, and almost everyone else is wondering how can anyone hate this, right? But trust me, I used to hate this so much that you won't believe it. Even I agree it is easy. I'm not saying this was tough, right? I'm saying it is very easy. But yeah, Krisha, I understand. But you know, the thing is that unlike most people, though my maths is, in my opinion, very good, right? Though my maths is, in my opinion, very good, right? But yet, I make lots of calculation mistakes, right? I'm very, very prone or very likely to make calculation mistakes, right? Okay. On the other hand, yes, I agree, it was easy chapter. On the other hand, I excel at algebra, I excel at trigonometry, geometry, calculus. See, it is almost like a rule. Those who love statistics will almost hate trigonometry. Right? Am I right or not? See, I have not asked you. I know this. Right? There are very few people like Divya here who like both, right? But you know the reason is that trigonometry is more like talking about relations between different things like sine, cos, and this and that, right? The same follows for geometry also. On the other hand, statistics is more like it's based on calculations, right? Isn't it? So these are two different aspects of maths, right? I'm not saying one is good or one is bad. Both are important and both are very useful, right? Both are very useful. Agreed, Falak. Absolutely, right? I don't want to make what you have said public because many people will not like that you are saying such a thing for statistics, right? But I agree with you that I also find it to be just like what you're saying. Anyways, coming back to this, so in any ways I'm not defending myself. Let me make it very clear. I'm not defending myself. A teacher making three mistakes cannot be defended, right? I took A, Vedant, but that was a long time ago now. Okay. Anyways, let's continue now. Let's continue. So this was meant to be some practice for you. This was meant to be for some practice for you. Okay, before we just wind this all side talk up, let me tell you that in 10th standard, I remember that the last question of the paper I did wrong. Okay, and what did I do wrong? You won't believe it. I did this. Okay, I did this. And and to my utter dismay, I got 99 marks. And there was no hurry, let me tell you that. I just realized it the moment I gave, or I just submitted the paper to the supervisor, right? And I stood up from my place thinking that it's going to be 100, right? Thinking that it's going to be 100, right? Just seconds later, I realized that, oh no, I made this horrible mistake, right? Anyways, coming back to physics now. Yes. In fact, I was very unhappy that I got 99. So those who are asking, are you that good in maths? You got 99. I'm going to say I was very unhappy that I got 99, right? Okay. Anyways, there's a lot to talk. It would be much more fun if all of this would happen in an actual classroom. Let's go to the next thing now. So, yesterday we have learned what is integration, right? Okay, we have got some basic idea about it. It's that you divide things into small parts and then add. So I told you that if you write v is equal to dx by dt, now we are going to learn integration use in physics. All right, how do we use integration in physics? Okay, sorry. Yeah. So v is equal to dx by dt, right? We already know that. So I told you that we can write this same relation in this manner, right? We can write the same relation in this manner. Okay. So now, if you remember, I mentioned, where did it go? I hope I can find what I wrote. Oh, it's been so many pages. Yeah, here. I wrote that when we add VDT, that is, we add all the small displacements, right? When we add all the small displacements, and we are basically adding VDT, so that's what we are doing integration, and we are getting delta x. So finally, what I'm saying is, if we integrate this, okay, so see, it's just like this. If x is 3, you can square both sides. Agreed? So squaring is a process, right? Just like that, here we are integrating. Just like that, here we are integrating. Make sense, everyone? Okay? Right? So just like we can square both sides, we can integrate both sides. Understood? Fine, fine, fine. Let's continue. So now you have to write limits. When time is t1 means initial time, to t2 that is final time. All right, see, I'm writing t because this is dt. If you remember, I told you that this is nonsense, right? You have to write d something. So of course we have dt here, right? Can we cut integrations if we require? No way, right? Okay, later on, if you are going to study maths, right? Maybe somewhere in JEE, you will use something called Newton-Leibniz theorem. All right, okay, in maths, okay, not in physics. So this is for maths people. At that time you will learn how to handle when there is integration on both sides. Okay, then you can do some special techniques, right? But I don't think I need to talk about that in a physics class, right? Okay, so here, because this is dt, because this is dt, right? Falak, you are going to get tired of hearing Newton's name, I promise. Because this is dt, we are writing t and t, and because this is dx, we should write x1 and x2. Okay, I'm concerned about limits. Are limits clear to all of you? Are limits clear to all of you? I'm concerned about limits. Are the limits clear to all of you? Again, the idea is this is initial and final, right? So similarly, this is initial, final. All right, That is when time is t1, what is position? It's x1. When time is t2, what is position? It's x2, like that. Okay. So now let's continue. What is integration dx? What's integration dx? Everyone, what is integration dx? People, hurry up. What is integration dx? ચલો રૂલ્સ તો આવડી ગયા છે, વાંધો નહીં. So x limits x1 x2 is equal to, on the right side, we can't do anything. I'll tell you why. See, some of you might be thinking, can't we write this like this? I'll say no, big no here. I hope you see it is not this, right? I hope everyone sees the difference. Okay. This would actually be v square by 2. This is right. But this is wrong. Okay, so you can't do anything with it. Right? We can't do anything with this at the moment. We have to leave it like that. So now here, can you scroll up? Why? What happened? Yeah. So now, what we are going to do is, instead of x, we are going to put the upper and lower limits. Instead of x, we are going to put the upper and lower limit. So x2 for x1, right? Minus, put x1 is equal to integration t1 to t2 v dt. Okay. Is this absolutely clear? What is x2 minus x1? People, what is x2 minus x1? What is x2 minus x1? Very good. Ami, Rishabh, well done. Yes, well done, all of you. I would like all of you to recall what we have learned. x2 minus x1 is? It is delta x, or displacement, isn't it? This is displacement. So, do you realize we have got a final relation? What's that? Okay, that delta x is nothing but the integration of v dt from t1 to t2, right? Okay, this is a very important formula. And in my view, these are two sides of the same coin. I hope you realize what I'm saying. Because this is in form of differentiation and this is in form of integration, right? These are two sides of the same coin, right? Okay. Will you be able to remember this formula? Okay. Along with this, what we have is that, yes, see, to do this integration process, to get the final answer, of course you need to know, or maybe it would be given in the question, right? You need to know what is t1 and what is t2, right? Otherwise you cannot complete it, right? So of course you need to know that, right? Now I just want to comment upon this formula, right, before we proceed. See, we have one more formula for delta x that we have studied earlier. V0t plus half a t square. Agreed? Everyone remembers that? Right? When can this be used? I'm asking you. When can this be used? Can you answer that? Everyone, when can this be used? Yes, very good. and I would request all of you to reply, okay? If you will give your answer and suppose it might be wrong, then I might be able to point it out. No, Princey, it is when acceleration is constant, right? There are two Princes, right? This is only possible if acceleration is constant, right? Okay. Yeah. But but of course but of course you know what's the advantage of the formula written above, the integration one, right? The one with integration. The good thing about this formula is it is always true, right? You don't have to worry about anything. This formula is always true, right? Okay, it's not even necessary that acceleration is constant, right? Acceleration may be constant, may not be constant, may be anything, we don't care, right? This formula, yes, no matter the situation, this is always true, right? So you see, this is actually a superior formula. I hope you understand what I'm saying. This formula is actually a superior formula. All right? Yes. Okay. But of course, you should understand that this is tough to use. Why? Because you have to do integration, right? Yes, Rahul, that's right. You can use it in any situation, right? This formula will be correct. I'm not saying it will always give you the answer. Sometimes you don't know what is T1, then what will you do, right? I'm not saying that it will always give you the answer, but what I'm saying is this is like a rule of nature. This is always correct. Okay. Now, let's go to a similar relation. All right, let's go to a similar relation. But this time it's about acceleration. I'm sure all of you understand this, right? So you see the similarities. We have v is equal to dx by dt, and then from that we got delta x equal to integration v dt from t1 to t2. Agreed? Kunal, I'm not so sure I understand your question. What can you not understand, Nandini? We did all this procedure. Look at this, Nandini. Right? Just like you can square, if x is 3, you can square both sides and write this, right? Okay? So just like that, if dx is v dt, you can do integration on both sides, right? Here we have done integration on both sides, right? Okay? What is meant by v dt? It is v into dt. Don't forget, v into dt is giving us small displacement, right? V into dt is giving us small displacement, right? So addition or integration of small displacement, I repeat, integration of small displacement means addition of all the small displacement gives us total displacement. I hope that is clear. Yes, this formula is calculus. Yes, agreed. This is the calculus method, right? Again, I hope you all remember what is integration. Integration is the task of dividing into infinite symbol, right? Dividing into very small parts, and then adding all that, right? So when you add all that, that's called integration. So what we are doing is we are taking the small displacement dx, which is equal to v dt, and then we are adding it or we are integrating it, right? Yeah, of course, Vedant. What you said, that's exactly what we have done, right? Okay, fine. Let's continue with what I was going to say. Let's continue. Okay. So it is that have a look at the relations. See, we have already derived this, right? I hope you realize we have already explained this line, right? That's what I've been talking about today, correct? After we solve those questions, right? Those homework questions, then that's what I've explained today, how we get that, right? Okay. So now, same thing. Look at the form. These are looking like similar equations. So do you realize that we will get another relation like this? Yes or no? Did you understand this? Yes or no, everyone? Right? If you want to prove it, you have to follow you have to follow exactly the same steps here, but start not with this, okay, but start with a is equal to dv by dt. All right, if you start with that and follow similar procedure, you're going to get this relation. Clear? Okay. Exactly, Vedant. We are integrating formulas that we have already written. Okay. Yes, I mean, nobody, see, listen to this carefully. You know, how you get this equation from that is not really very important in physics, because like I said, it's a basic of maths, right? If you think about it, it's just related to basics of maths, that you have this equation and then you do integration, so you get this relation. Okay, but yes, you can remember these. Okay, they are useful in physics, right? એનું ડેરિવેશન કંઈ એવું મોટું નથી. Again, if you have v is equal to dx by dt, you just have to write dx equal to v dt, and then in next step put integration sign, એટલે ચાલુ થઈ ગયું. I hope you understand what I'm saying, right? It's that simple. Okay, right? Okay, fine. Let's continue. Okay, so now we have two relations. Okay, now we have two relations. Which one? And two. And both these relations, again, they are valid even if acceleration is not constant, that is in any case. So for example, this is first equation of kinematics. You can only use this if acceleration is constant, but for this relation there is no such problem, right? For this relation there is no such problem. So once again, this is the superior version, right, of this one. Okay, I hope you understood that, right? This has some limitation, right? Limitation means it has a condition, right? You can only use it if acceleration is constant. But now for this integration equation, there is no such problem. You can always use it, right? Delta V, delta, not D. Okay, delta V. This is clearly delta V. See, everyone, it was dV. Over here it was dV. But then when you do integration, integration of dv will become v, and then you have to put limits, v1 and v2, or v0 and v. Make sense? Oh, sorry. Right? So when you will put this, and you will get final velocity minus initial velocity, what do you think this should be called? Final velocity minus initial velocity is nothing but delta v, correct? Right? Okay, so that is how it comes into the play here, right? So fine, so these are two important relations, Okay, so once again, let me just write these two. Delta x is integration of v dt from t1 to t2. આ ગોખાઈ જ જવું જોઈએ, એટલી બધી વખત કરવાનું છે. And delta v is equal to integration of t1 to t2 a dt, all right, of a dt. Clear? Now, you see, frankly, I'm not very surprised by this. I'll tell you why. I'll tell you why. Look at this. You take position. Okay. These two are formulas that we have been talking about today. If you think of position, that is x, and you do its differentiation, that means you do dx by dt, right? Okay. Okay. So if you do its differentiation, you get velocity. Agreed? Agreed? Then further, if you take velocity and you do its differentiation, then you get acceleration. No, it's not that. When I'll explain the logic, you will understand this, right? It's not because I know it already, so I can relate with it. Okay. Is this clear? Right? What I've written here is clear or not? I want to know your opinion. Is this clear? Okay. What sort of this is perfect, people. V is equal to dx by dt means differentiation of x is giving v, and then a is equal to dv by dt means differentiation of v is giving a, right? Okay, I don't think there can be any doubt about that. What's not clear properly? Nandini, what is not clear about this? This is something that we have learned so early in the chapter, right? અરે આવા સમસે કેટલા બધા કરી નાખ્યા હતા. All right, Vedant. Okay. So now, do you remember I wrote a line that integration and differentiation are opposite process? Yes or no? Do you remember this? Hurry up, people. Yes or no? Fine. Okay. Okay. So, it is quite natural that if you take acceleration and you do its integration, you should get velocity. Agreed? Yes or no? Because differentiation and integration are opposite processes, I believe you will understand this fairly easily, right? Because integration and differentiation are opposite processes. Integration of acceleration should give velocity. And it does. It does. Have a look at this relation. Have a look at this relation. When you do integration of a with dt, because you did differentiation with dt, you should also do integration with dt. All right, that's the rule. Okay, so integration of a is giving you v, but why not v? Here we are getting delta v. Well, that's strange. It's not strange. It's because whenever you do integration and then you put the lower limit and the upper limit, and you always do a subtraction, correct? And you always do a subtraction, right? That's why instead of getting v, you are getting final velocity minus initial velocity. That's not called v, it is called delta v. Exactly, you get the change, right? Because we are putting upper limit minus lower limit, right? We are doing that. So we are subtracting. And when we subtract, we always get the change, that is delta, right? So I hope you realize that mathematically, this equation and this equation are just the same. રાઈટ. તમે કોઈ મેથેમેટિશિયન ને પૂછશો કે આ બે શું છે તો કહેશે એક જ છે. રાઈટ. બરાબર ને, આમ ઊંધું કરીને જોયું એટલે ઊંધું દેખાય છે. ઓકે. મેની પીપલ હેવ સ્ટાર્ટેડ ફ્લીઈંગ, બધા ટાઈમ થઈ ગયો છે. પીપલ ડોન્ટ રન અવે. છેલ્લી 5 મિનિટમાં ઘણું કામનું આવે. રાઈટ. હવે તો આઈ એમ શ્યોર whenever cinema halls would open again, you are going to do the same, right? If it's a 2.5 hour movie, right, you will sit there for 140 minutes, right? And when it's about to end, when there is climax of the movie in the last 10 minutes, you will leave. All right, wonderful. Congratulations for this great behavior. Right? So please don't do that. Okay? Never mind. So next step, if you do integration of velocity, we should get x, of course, right? I don't think that should surprise anyone, right? But we still don't get position, because when we put upper and lower limit, we have to subtract, so we get delta x, right? So again, in my opinion, and if you look at the maths carefully, these two are same relations. Clear? This is written in form of differentiation, and this is written in form of integration. આનું એક એવું એક્ઝામ્પલ આપી દઉં જે તમને સમજાઈ જાય, એટલે આ પૂરું કરીએ. Someone will say root x equal to 3, right? And someone will say x is equal to 9, right? Okay, so whether you write this, okay, this writing like this has the same meaning as writing like this, does it? If x is greater than 0. એટલે વધારે પડતું મેથ્સ જેને આવડી ગયું હોય મારી જેમ, એ કઈ બોલે પહેલા. Okay. So this you are writing in form of square root, and this you are not writing with a square root, but both mean the same thing. એવું જ છે આ. Both of these mean the same thing. All right, so that's it. And I promise you that this was the longest stretch. I promise you this was the longest stretch of maths that I have taught you. Okay, that does not mean we are not going to study any more maths, right? That does not mean we are going to stop studying maths. We will study maths, of course, but not so much, right? Okay. Physics part was very small. Okay. Yeah, you might think about that, but trust me, now all these maths and some more maths will come back to you, and when we are going to do physics, right? Okay. uh, Now we just have 1 minute. I cannot start the next chapter, right? Okay. Maths part is more, I agree, right? This chapter is over, yes, for all practical purposes, right? I don't want to cover anything more from this chapter, all right? In fact, this integration thing was also not a part of this chapter, right? Okay, but it's a common thing, right? It's not like you are going to use integration only in this chapter, right? Okay. No, projectile motion is still a long way to go, right? We still have vectors. Exercise questions and examples are left. Those are left. That's it. Okay, if you want, you can try those. Okay, like I mentioned, we will not solve all questions from the exercise, right? Like I said, it is what, Kunal? No, that's impossible to do. I'm so sorry. I cannot cover the whole lesson two's exercise. Yes, I will give us important. I will give you all important points, of course, right? Okay, we have covered something important today. I'll also give you one or two homework questions regarding integration, right? About the use of these formulas that we have learned today. All right? Okay. So with that, we're going to wind it up. We are of course going to start with next chapter, Rahul, right? Goodbye, everyone.